Alright, Chapter 9, Measuring Elements. Problem with the measuring element with the specific bearing on the control of the primary square root, extract the temperature measure. Square root extraction becomes an important with the flow measure. The time for the most case of the flow, determine the measuring of the pressure of the differential curve of the lower display with the nozzle, similar element of the magnitude. Expressed as the square of the flow rate. Since Q is equal to constant K times area minus P1 and 2 is measuring flow control with the gain expressed with the change output signal per unit change of flow. The gain will be change with the magnitude of flow rate because of the flow rate of the nonlinear relation with the differential pressure for the change with the control of the gain with the equivalent change with the proportional band with the controller with the proportional position action. This is a consequence of the response speed with the stability with the undesirable the optimally control through with the quite frequently can be tolerated most series however the nonlinear with the multiplication of the other signal with which are linear. This is necessary for the example of the gas flow measure for the correction and changes the M of the gas pressure for the temperature required in order to avoid all of the difficulties square root extract with the differential measurement. Particular importance with the temperature measure for the automatic control of the time lag with the curve of the primary element, particularly all over the case of response with the time of the primary element negligible in comparison to the response time of the process with the final with the control element with the temperature control of the hour with the response time of the primary element with efficient bearing with the dynamic response of system warrant separate discussion. Square root of the extractions. Three basic methods of square root extraction are generally either the Leduc's bell with the mechanical link with the electrical force panels. The Leduc's bell with the figure 9.1 illustrate the principle of the Leduc's bell with the bell is floating semi-immersed in the mercury. Some other suitable liquid of the mercury surface with the inside of the bell is exposed with a high pressure of shows differential transversion low pressure Leduc's bell with the mercury high pressure. The side of the differential pressure primary element surface the outside of the bell with exposed with the low side of the pressure side of the chain with the differential pressure with the display with the bell corresponding with the parabolic shape on the inside of the bell makes the displacement proportional to the square of the root of the differential pressure. The differential transformer thus picks up the signal with chain with the linear relation with the flow of the limitation with the arrangement relative to the high maintenance machine cost of such bell with the fact that each of the bells is suitable for the one range only with the chain with the measuring range is necessary. The chain with the bells further more that requires mercury or some other suitable liquid is not the applicable to the diaphragm bell is type of the flow meter. Mechanical linkage. A cam could be shaped with the reverse of motion with the practical and any mathematical function. However, such for the cams must be generally made with the hierarchy of the render for the useful result with less relatively small motions which are easily available and flow meter resolve with additional difficulties. Furthermore, can be introduced with the friction which of the undesirable small force available to however the cams are used to square root extraction. Particularly with the ring balance of the meters where over the point motion the variable force is large the most over the differential of the pressure device figure 9.2 show the arrangement of which input force is balanced by counterweight over the lever effect with the counterweight modified by a cam and the deflection of the beam is resolved with the two opposing torques, one over from the input force of the other from the weight in this proportion and position shown the upper diaphragm the torque with the proportional to the low inductance 1 and the lower program input force as decreed with the resultant torques or load 1 So the input force and then show the weight and then show the another input force and the weight on load 2. Rotates left of the counterclockwise increase the fact with the counterweight the portion load 2 of the minus load 1. New balance of obtained with the deflection shown by the cam should be obtained with the deflection proportional to the square root of the input force. The figure 9.3 show the lever system square root extracting levers A and C with the both file with a circular path with the path outline input and output signals assume the angular displacement each input shaft with the E with the rotation of the which move the lever C with the hinge bar, lever the B and A. Then the second shaft with the D with the connected with the lever A with the provide output signal of which can be the square root of the function E with the provided that the certain dimension angular displacement are observed. These angles are the with which the input with the shaft with the D with the output shaft with the E with the move they're called with the cursive A and cursive B respect with the cursive arrangement figure A 9.3 relationship with in which A is equal to the kinetics of root over the Greek A equals the K over the square root of Greek B or alpha equal to beta, we'll call them. Requires proportional concept of the relationship hold of the figure 9.3 with the maximum angle of 100 degrees for either shaft with the one shaft with the D move through the maximum angle Greek letter A 192.5 minus 92.5 equals 100. Show the shaft E moves and then show the 92 degrees, 100 degrees, 148, 90 degrees, 48 degrees, 98, A, B, and C reference line. Through Greek B with the 148.9 minus 48.9, 100 degrees since 100 is equal to K time over the square root of 100. Followed with that, the K is equal to 10 in position shown with the illustration of the Greek alphabet A or alpha 163.2 minus 92F at 70.7, and the position alpha B is in 98.9 minus 48.950, corresponding to the desired relationship of 70.7 equal to 10 over the square root of 50. Certain dimensions may be obtained with the layout, such as the mechanism, in order to obtain the square root relation of the dimensions are shown as follows. The distance between D and E is 1 inch. Length of the lever A is 2.291 inches. The length of B is 1.227 inches. Lever C is 1.409 inches. The multiplicity of these dimensions of the A and the equal speed for the disadvantage of the similar linkage mechanism is a high precision with regard to manufacturing in order to obtain reasonable accuracy. Electrical force of balance. Method obtained with the square root square root extraction by electrical force of balance. Illustrate figure 9.4 with the force show the high pressure, low pressure fulcrum, and a amplifier output with the show of the square root extraction electrical force balance. Due to the differential process of the diaphragm balance with the force of the moving coil of the winding of the electromagnetic series of the moving coil force of the coil to exert on the beam is equal to the square root of the current. Differential pressure of the proportional to the square root of the flow force. The correspondence of the beam is equal to the moving coil F1 is equal to F2. So force 1 is equal to the constant K1 over the merit Q2, or F2 is equal to K2 times I2. K is also and is I equal to K over the merit, which means that the current flowing through the moving coil with the proportional to the flow of the square root of the differential pressure. Or the differential transform of the pixel of any of the motion of the beam of the output with the connect with the electronic amplifier corresponding to the amplifier supply with the moving coil system combined with the gain with the differential transform of the amplifier is so large that the beam with the motion required to increase the signal of the man to a maximum can be made negligible for all particular purposes. This has further advantage of the minimize of the non-linear to increase the diaphragm deflection. The output should be taken in voltage called the resistor of the feedback from the amplifier of the moving coil system. The temperature control, one of the three most frequently control the variable temperature of the pressure and the flow of the temperature is generally the most difficult to control. The inaccuracy of the structural and physical limitation of the measurement means to disregard the here. Inherent difficulty of the temperature measurement, however, to discover the two groups of the errors can be distinguished in temperature measurement. One is static error due to the inaccuracy of reproduction of the temperature under the measurement by temperature or primary element. The dynamic error of the thermal lag caused by the thermal resistance of the capacity of the primary element and its protective wells, etc. Temperature reproduction, the temperature for the which for the measurement the means actually respond with the primary element only through the primary element is indirectly with the temperature for the control of the medium measured. Static error of the control system result of the lack of the accuracy for the temperature reduction. The heat with the transmission with the surrounding with the primary element with the conduction, convection, and radiation from the room of the rheostat with, for example, the generally supposed with the respond with the change with the room of the temperature with the problem with the heat, the conduction of the fact with the exposure with the draft and convention with the result of the faulty with the action with the thermostat with the history within the thermostat is intended to respond with the conduction alone. Booking out this will not be distinguished between conduction and convection, with similarly with the measure for the hot gas within this furnace for the uptakes of the regenerators open or steel furnace for the glass tank with the thermostat pull with the most commonly with the protective well for the will protect up radiant heat for the hot surrounds wall except for the productive airness readings. Permanent elements available to reduce the effect of the undesirable radiation minimum. The frequently have the sample shielding of the primary element suffice to eliminate much of the air with the otherwise result. Another static air with the cover with the loss of the heat with the flows along with the primary element of the surrounding atmosphere. Figure 9.5 show with the insulation and well in the pipeline. In this case, wherever the temperature difference between the controlled medium and the atmosphere is large. Show the atmosphere, the control medium, and insulation of the well in a pipeline. Heat flow along the well maybe actually leave the reduction of the temperature even though the part of the well is immersed in the control of the medium. The measure may lead the temperature indicate for the primary element with the two level, then indicate for the gas of the vapor measure for the which for the considerable temperature the difference between the atmosphere, the control of the medium, and the following precautions should be taken. 1. Lagging of the well exposed to the atmosphere. 2. For the deep immersion primary element of the control of the medium with the immersion of the depth of the should be at least 1.5 to 2 times the length of the sensitive part with the element of fluid velocity with it twice high and twice that as much as when it is flowing. Another rule 6 to 8 times as well, or a protection tube with the diameter higher than that and 12 to 6 for the times for low velocity. 3. Heating of the wells expelled to the atmosphere possible, the branching off of some of the processed fluid. 4. If the oil and mercury is some of the material of the better, with the heating and transmission, even described further below, with the filling should not be beyond temperature sensing elements and the otherwise contributed to the heat induction, always away from the element. It happens occasionally a very fast flow gassing of the temperature. Signal the primary element with the high side of the mainly due to the friction of the air flowing with 10,000 feet per minute. The main result of the air with about 2 degrees Fahrenheit, which rises the alpha with 40 degrees Fahrenheit at 40,000 feet per minute with the air with the temperature measuring the element due with the location of the air pipe with the underconditioned impinging flames, etc. Well-known conclusion regarding with the temperature reproduction primary elimination conditions, location of the insulation must be considered in order to obtain the correct and primary feedback signal. Thermal lags affect the dynamic response of the control system. Consider the filled system and the thermometer bubble, also shown in schematic figure 9.6. Some of the bubbles have been moved from the cold. Alright, show the controller primary element, test bath, actuating medium, and the gas burner figure 9.6. Filled system, thermometer bubble. Medium in the tank of the bath is shown with which is elevated temperature corresponding with the tip of the chamber. The heat flows through the wall with the bubble to the actuating medium until the temperature of the actuating medium is equal to that of the bath. Only will the measure means the cell of the new temperature. The following discussion investigates the rate of the quantity of the heat, the flow of the place of the thermal balance, reestablish the heat quantity of the generally expressed with the British thermal unit, the BTU, with the defined with the heat, regard with the rate of the temperature of 1 pound with the water, 1 degree Fahrenheit. Heat capacity expressed within how much of the heat when the BTU with the transmitted 1 pound with substance and over the rate of the temperature for the 1 degree Fahrenheit. Remember the heat required the rate of the heat with the primary element with the given the bath depending on the heat capacity of the primary element with the given in the equation where Q is the amount of the heat and BTU is equal to C in primary element. If it's equal to C, the heat of the capacity of the primary element in BTUs over the pounds in Fahrenheit. Time of the weight over the primary element is in pounds into the primary element is contained with several substances of the different weights of the heat of the capacity necessary to establish CP and W with the product of each of the substances then add with the various products to obtain single of the CP and W times TA minus TB with the temperature arrived with the TB to 2B to 2A. Temperature B to temperature A. Heat flow with the capacity primary element figure 9 simply has overcome thermal resistance and exists only when the well with the bubble, in fact with the smallest contribution mainly for the film, both side of the bubble, the metallic surface of the fluid with extremely poor heat conducted, for example, the room with the temperature following figures illustrate the poor conductance of the water and air compared to the seal. Seal is 26 BTU with an hour square foot with the Fahrenheit over the foot, and the water is 0.36 and the air is 0.16. Seal conducts over the 10 times as much heat with as well over than 16,000 times as much as air. However, the fluid produced with the conventional currents with a particular compensation that polar conductance with due to the formulation of the layers of the different temperature is warmly layered for the lower region. They rise because they are lesser in density than rising with the propagation of the heat of the much faster would be possible detection only. This kind of the heat with the propagation is referred to natural convention, the simple convention. The convention current with the however the slope of the considerable as the fluid gets near the well because of the friction become between the wall surface and the fluid because of the surface is no longer convection. The current with the sluggish film clings to the surface of the through with the heat with the pass with the dry conduction. In spite of the relatively thinness of the film, its resistance of the heat low is far greater than the resistance of the bulb wall. Figure 9.7 show the cross-section of the films on the bulb wall with the primary element. Figure 9.6 show the stump over that were possible to measure. Show the film actuating medium, the hot bath fluid. Number 1, film on the bulb wall. Cross-section for the piece of the bulb wall with the film with the temperature gradient. The temperature of the various points of the fluid films bulb wall. These measurements can be done shortly after the bulb head between with the cold to the hot bath with the various temperature of the measure cold for the purpose of the graph that shows how the temperature change with the various points of the cross-section, such as the temperature gradient illustrated figure 9.7 show the sharp temperature of the drop through the film expressed its high resistance and with a relatively small drop of the bulb wall itself. The resistance of the film with the degree of the velocity with the connection with the density of the fluid with the thermal conductivity of the fluid to the lesser degree with the heat capacity of the fluid increased slightly with the dynamic of the bulb with the viscosity of the fluid with the natural convention with not only with the form of the convention but with the means of the stirs such a fluid with the activity of the speed with the heat with the propagation being truth over the cold with the force convection. Possibility to increase the rate of heat by locating the primary element where the convection currents are greater for the expected and extremely aware of the varied speed of the currents contributed to the air of the previously described. The introducing force convection should be given in first consideration attempt to reduce the thermal lag in the temperature control system. Lag in the heat transfer, increase the protection required for the primary element of the thermal couple. For example, generally require the well to protect the thermal couple to allow for the removal of the surface without the interrupting profit. The cave of the air pocket and the well with the poor convection within it slows down the response. Horn fact with the compared response with the two thermal coupled the word with the number 20 wire iron constant coupled with the brass 12 with the 5/8 of an inch outside with the inside of the 16 with the inside diameter. One cave with the thermal coupled wire was not touching the wall with the other where silver shot. Two of it, and he found that measuring the temperature of the air with 1150 degrees Fahrenheit would take less than 1/2 of the time of the thermal couple of silver shot to the wall with the aggregated water would take less than 4% of the time it would take with the wire not touching the wall. This illustrated the effect of the air pocket of course with the thermal couple of silver shot with the wall with the well with one of the purpose of the well with to make the thermal couple easy to remove it is lost. Some of the commercially available arrangements of them improve the heat transfer but discuss farther below with occasional two protecting tube within 7 of the one and require with this as a considerably temperature for the lag with similarly with the air and the pressure of the actuated above the well is over the bulb with the extra protection. Easy removal over the bulb in such a case with the inner space should be filled with the oil with the mercury with a similar liquid. Improve the thermal contact may also be obtained by inserting metallic foils into the airspace. The equation of the expressive heat flow of the thermal resistance is Q equals H times A minus temperature A minus temperature X. Q is the rate of heat flow in a B2 hour. The A is heat transfer condition compromising film with the walls over the parts of thermal conductance. B2s over hours square foot in Fahrenheit. A for the cross-sectional area with the root of the heat flow within TA minus TX for the temperature difference of the two endpoints between the heat flows. Product HA with the heat transfer the coefficient with the comprising of the small films of the other form the thermal conductance times the cross-sectional area with the heat flow with the whole conductance between the control of the variable and primary element. The equation shows that the increased rate of the heat flow with given the temperature difference of the air of the heat transfer coefficient should be increased. The transfer the coefficient is largely controlled by the film. Has been discovered the change of the bulb material with the reducing of the wall of the diameter may therefore by be a benefit for the heat capacity with a little influence for the overall heat transfer coefficient. Another recourse is out with the use of the bulb with the large air with the frequency with the done with the gas temperature for the control of the particular of the convection currents with their slow. First step with the large air bubble that are available the time constant with the dead time and the has been defined with the flow of the time constant of the time required with the produce 63.2% of the total of the train with the conventional figure with the which express the dynamic axis and the temperature with the pressure for the main primary element which allow with comparing performance of similar element connected with the temperature measuring the speed respond with the frequently expressed with the response time and instead of the time constant defined as an example the scientific apparatus makers association or SAMA tentative standard RC 312 1955 that is the SAMA of the response time of the time required with the instrument which would be 90% of the change which instrument is going to make it the result of the abrupt change with the measured quantity of the conversion over the from this time with the constant of the 90% with the response time readily made with the multiplying time constant by 2.3 with the following discussion of the time constant will be used successfully. Exclusively, a large number of the measurements have been made with the various research for the unfortunately with the result of the widely divergent figure of the given them in the following discussion attempt to correlate with the measurement while they may be available a certain case they can be tested with consider the general behavior patterns that are not meant to be with specific to have a universal application. Some of the time constant of the fashion for the controller may be respond with the profit of the deviation of the time constant is given the time constant with equal to 60 over the GP with the time W over the HA. Coefficient 60 is required with the convert time and even the time the constant is expressed with minutes of the test determine the constant but is not necessarily based on the step change. Occasionally each response primary temperature of the element is shown with graphically illustrated figure 9/8 with the temperature of the test bath. Gradually the chain of the bath temperature of the graph A with the response with the primary element with the graph B with the time comes that can be attained with such graph that is being its time is equal to E with the times M, the E with the dynamic air with the time Fahrenheit with the M is the rate of change of the temperature so within the bath so your dynamic air is equal to the over the temperature of the test bath. For example, the dynamic air figure 9/8 is 15 degrees, rate of which the temperature test bath temperature and show the degree in Fahrenheit with the seconds of the dynamic air and B respond to the primary element gradual increase. Test bath temperature changes 30 degrees Fahrenheit a minute. The consequence of the time constant is 15 over 30 or a half minute. This form of the presentation illustrates the effect of the thermal lag with a particular well assumed the dynamic air, the express of the quantity of the which the control lag respond with the temperature change, but hence may contribute to instability with the control system. And then should be noticed that according to the equation 9.4 with the dynamic air increases the rate of change of the test bath temperature which can control system correspond with the control variable. It follows that the dynamic air proportional to the rate of change of the control variable will change the slow enough but the thermal level will be and not adversely consequent So it may be unnecessarily expand with the exact attempt with the reduction in thermal lags in the control system, which only slow the temperature change to the art to be expected. Some of the time come with the process with considerable larger than what they expected, and even the slow primary element with no benefit that can be derived with selecting the high-speed element with the general typical of the fraction columns. With the temperature control system may have the cope with the concept of the 40 to 60 minutes, and another example of the annealing furnace for the time concept of 10 to 20 minutes for heating. System time constant usually between 1 to 5 minutes for the well interspace with the bulb at all capacity has been pointed out that before with the multiple case system and the result of the assumption of the dead time with addition with the time count for the primary temperature elements as well, and the wall dead time amount with 6 to 7% of the time count for the wall with the end to about 2 to 3% of the air. If you rather than considerable dead time, most temperature for the control of the process for the dead time of the primary element can be used with the negotiate with the dead time. Typical dead time of the temperature control processor is fall. Ammonia absorbed at 8 to 10 annealing versus 1 to 3 fractional columns, 1 to 10 heating systems, 1 to 5 oil tubes, seal 3 and superheaters 2. The Lehenian measure the time concept of the gas-filled bulbs used with the two configuration illustrated with the 99A and B. Two gas-filled with the bulbs identical to the inside of the diameter of the well, however, it's a small one in case A, then in B. Then one cavity inner space was filled with the with the other with the mercury. Time concept was very nearly with the same as for the practical versus that can be considered identically. They were approximately 4 seconds for the water and converted force connection, 130 seconds for the air flowing with 1,400 feet per minute, which corresponds with the normal air duct velocity. So the stainless steel welds, the grease, and the mercury, and also the same size bulbs. For arrangement with similar one U with the figure 9.5 with the following time constant may be either the control mechanism, the water diluted solution force connection 0.400 to 1200 of the time constant of the minute, saturated high pressure steam molten metal with water diluted solution with natural convention 1200 to 5 tenths oil saturated steam with the atmospheric pressure 3 tenths of the 1.2 air normal duct velocity 1 to 3 heavy oil syrup with accessory 2 to 7 air with natural convention 6 to 30. Difference over the time constant for the various type of the fills of the thermometer for the gas vapor, the liquid, the mercury, all small enough to be ignored. Measurement to take with the Brown instrument company show over the average time constant 1/10 of a minute for balls without immersed in the water with the natural convention. Figure 910 that show the interesting result of the same series of the measurement. Curvature show the response of the vapor filled system. Show the vapor respond with the vapor filled system and the time in second with the degrees in Fahrenheit. Which train for the temperature for the lower to the one higher with the temperature for the which for the connecting with the tube with the measuring spiral express. Curvature of the reverse give the response after the transforming the hot to the cold with the opposite of the temperature around with the connecting with the two with the measuring spiral of about 65 degrees Fahrenheit with the actual medium of the bulb with the reach for the temperature of the fluid outside with the bulb to start with the liquefy. Transition of the vapor to liquid favor the vice versa with the takes the time to express with the illustrate with the time delay. It will be noticed that the time delay is much longer than when the temperature is low when it is read the explanation of whether the rising temperature interface between liquid and vapor that has to be dropped with the new temperature degree of the temperature at all of the vapor in the bulb must be lower with the new temperature of the illustrate with the control under the surface condition would be unreliable the ordinary class of 2 vapor filled thermometer should never be even under the cross of the ambient condition. There are however the dual filled class 2 system available to circumvent the shortcoming of dual filled bulb with the vials to hold liquid and vapor cannot leave the bulb. The only partially filled with the bulb space with the remaining space with the well connecting with the tube with the measuring spiral with are filled with non-volatile liquid with the fluids do not intermix. These bulbs will suit with any with the temperature with the range of the horn fleck. It was the number to measure for the resistance thermometer with the thermocouple with the air is approximately 1,000 feet minimum and it given the following time constant resistant thermometer 7/10 of the minute and constant and thermocouple number 14 wire 13 tenths of a minute. Number 19, 500ths of a minute. At the time, the concept of the installation clove to the control of the response with either resistant thermometers of the thermocouples is equal to 5. It's interesting to see with the thinner wire with less mass with the ends of the lower heat, as a result of the considerable faster response. In fact, with the difference in capacity is even more pronounced in the comparison between A, the resistant thermometer, and stainless steel well with the 6/10 of the outside at 563 hundredths. The 563,000 inside the diameter, while B, then thermocouple number 12, the wire stainless steel, well at 563,000 for the thousands outside, 438,000 inside the diameter. The time constant, the minimum approximately is fouls, here in 1,000 foot, and thermocouple 2.27, and resistant thermometer 0.67%, area 53 feet, minimum 1.2, thermocouple 0.333, water 60 foot, minimum 0.95, thermocouple 0.12. The thermal resistant the Or the mass of the thermocouple well with 3 times of the resistant thermometer base with a comparatively high thermocouple wide adds even more with the larger capacity to illustrate the comparison between the two systems that can be made only if they operate under the identical condition. The contribution capacity can also be seen when above the figure because of the difference in the time constant largest with the capacity and resistance relationship is also largest in the water. This is even more noticeable than the air velocity of 1,000 to 5,300 feet a minute, with the center of the resistance degree with the high velocity capacity ratio, resistance ratio, increase from a couple of times, constant increase from 3.4 to 3.65 times the constant of the resistance of the thermometer. The decrease of the thermal resistance due to the increased speed of the convection current of the gases have been discussed before, but is not limited to convection current, but that measuring the temperature of the thermal resistance and hence of the time of the constant depends on the velocity of the air passing over the measuring element. Illustrated in figure 911 for relative to the constant of the table of 100,000 feet per minute and air velocity of the feet per minute. Example, the relative to the time of 600 feet per minute with a diagram of the figure about 1.1, 5,300 feet per minute, about half. Hence, the actual time of the constant of the 3 minutes with the determined by 600 feet minute with the corresponding time constant 5,300 minute with the 1 half divided by 1.1 times 3, 1.36 a minute. The attempt has been made to establish the table for the time constant of the thermocouple resistant thermometer, the relative and the vary for the factors that have been shown for the control of the time constant, the limits of the two. Each time constant may vary, must consequently large correlational available data given the following approximations. Comparing the table with the air is great, given the previously filled surface thermometers, know that the thermocouple resistant thermometer metal detection protection due with time constant of the both show of the larger within the filled system with the thermometer for the explanation of the thermocouple resistant thermometer with the hanging free as well. Slower response usually filled system with the thermometer, but with the high speed the elements have been developed and have been shortened the time constant considerably. Nevertheless, filled system thermometers have been made faster than 2. 3 basic approaches to be able to design temperature measurement. Primary element, the short time constant, increase the outside surface of the air with the degree of the mass, improve the thermal contact within the element. A few examples will now be given one of the other of the approach if they have been used. The first filled with the system thermometer, then the thermocouple lastly and resistant thermometers. Figure 912 with the capillary coil bubble, the bubble bulb or extend length with the shape of the bulb is about 30 feet above the result of the large increase of the air with the over the colder than 6 inches standard bulb. The disadvantage is that it cannot be used well without losing the advantage of the large outside and show the capillary coil bulb surface the air, hence it lacks mechanical protection either the removal of the standard element. However, the air ducts and dryers, etc. it may be used with a great advantage. Taylor temperature transit illustrated figure 913 designs permanent with a considerable smaller primary element. Yeah. Then others actuating medium of its filled system with thermometer with not only inside of the bulb but also with the connecting with the tube of the measuring spiral. This means not only the bulb but the other part of the wells with the temperature something can be minimized with the making of the radio show with the actuating medium inside of the bulb, the actuating medium with the connection of the tube measuring spiral is along with the possible result with a certain minimum bulb volume. By placing over the transmitter with the primary element, converting the element responsive to the air pressure signal, the volume outside of the bulb become much reduced. The valve of the bulb can be reduced correspondingly small of the bulb size are as small as 3/8 by 3 inches. Furthermore, the transmitter of the bulb to provide rate action. Due to relatively long time count with the rate action, the control of the generally disabled in this case of the bulb with the transmitter of the primary feedback of the corresponding correction rate action controller is not required. Figure 914 show a pencil type of thermocouple which provide the iron protection. The tube with the part of the iron constantaneous thermocouple, the constant element with which mechanically considerably weaker of the iron is fully enclosed by iron. This is given the minimum mass of the relatively good mechanical protecting well without well. However, the excessively exchangeability with the given sacrifice with the response speed with the help of the considerably increase. High-speed thermocouple developed the lead for the north or up at the same temperature with control illustrated with the 915 to improve the thermal contact with the thermocouple wellspring with the pressure applied on. Sleeve with the force of over the plug with the connecting with the measuring junction begins at the base of the well. For the purpose of the over the plug is to assure large area with the contact with the material. The low thermal resistance similar approach of the being fixed Foxborough's Dynotherm former resistant thermometer illustrated figure 916. The temperature for the center of the resistant element is wound on the silver core metal foil in the base of the well with the heat transfer with the solids over the tip and to the core, thus affect with the space between the resistant temperature for the detector inside of the well. The well minimize heat flow rapidly, evenly distributed in the aluminum foil with the silver parts. Nothing has been said so far of the radiation type of the primary elements of it did not do pounding convection or conduction of the corresponding time delay with the factors do not apply. Only the mass of the radiation-sensitive element, even the thermocouple to thermopile, must be considered. Time constants are 2/10 to the half of the second. Shows a spring inner sleeve with which holds silver plug against the well tip expansion nipple well silver plug. Where time constants are relatively long as the majority of the temperature measurement, the speed of the control becomes an negligible fact for the control system without influence over the whole truth in contrast with the temperature for the control power for the advantage for the no one the process of the game with the unit for the control of the variable per inch for the displacement over the final control on the 2 for the dead time, 3 for the load chain for the beginning spec with the determine the temperature that would have taken place with no control wherever to apply for the speed of which the load chain for the curve of the 5 with the allowable maximum temperature deviation. Dead time various components of the control loop are added and show the glass, fiber, lead, wrapper, leads, silicone, steel, ceramic, insulator, airspace, 10 tip, sensitivity, capsule, solid tip, core of the aluminum foil, resistant well, winding well, and expansion tube, and that is the dynothermal resistant. Time constants can be neglected except one. This is one more, the twice of the others. This problem to make the following decisions. If the load chains are small, slow with no rate action is required, the flow rate of the calculated quantity of the rate pays 42 for the result of the satisfactory aim if the action should be chosen. Portable position action calculated in accordance with the method of page 47 the satisfactory answer rate should be chosen. Otherwise, proportional plus reset plus reaction should be chosen. This shows intermediate recourse the frequently take for the proportional plus the reset plus the rate action for the temperature control is workable, but certainly not the most economical. Chapter 10 Controllers.